We are trying to graph and look at the features of an ellipse. So they're going to show us an ellipse. It's going to be below. They're asking for the center of it. The minor radius, also sometimes called the semi-minor axis, and the major radius or the semi-major axis. All right. So, and then they're asking, what are those? Okay, let's take a look. What do we have here? Okay, well, at this stage of the game, we're just eyeballing it and then just counting it out. So first, let's go ahead and look at the minor radius, or we would call it a minor distance or a minor length. And the semi-minor axis or the minor radius is just half of that. So kind of getting caught up in some of the terminology here. So let's just go ahead and do it. All right, so the minor, and that would be the smallest distance from the center going through the center, the smallest distance going through the center. That would be this right here. That would be the minor distance or length. I like to think of it as distance because in more complicated problems, we would be using the distance to find the length. And then we would divide that by 2 to get the minor radius. They also call it the semi-minor axis. Okay, so just eyeballing it, and it's kind of nice just to look at the points at this stage as we're getting used to it. So in this case, we got a 2.5. So that's 0, 2.5. X is 0, Y is 2.5. And going to 3.5, 0, 3.5. Okay, so this length right here, and like I said, if we needed to, we would use the distance formula. But right now, we can just eyeball it. That'd be 3.5 minus 2.5, which gives us 1. And so that's the minor length. And then for the minor radius or the semi-minor axis, we divide by 2. So 1 divided by 2. We can just look at it as a fraction. All right. So that would be the semi-minor radius or the semi-minor axis. All right. And let's go ahead and look at the other one. So that would be the major. First, we look at the length, the major length, and then we would use that information to divide by 2 to find the major radius. Sometimes called the semi-major axis. Okay, let's go ahead and change colors here a little bit. So right now, like I said, we're just doing an eyeball effect, but if we needed to, we would use the distance formula. So that would be from this side, cutting through the center. It's the longest length. All right. So that major length is at negative 3,3. And it goes to 3,3. All right, so if you weren't able to eyeball it, then we would have to use the distance formula. But in this case, so we'd be looking at the distance from 3 to negative 3. How has that changed? So we're just subtracting those 2. 3 plus 3 is our 6. But like I said, we can do the distance just by counting it out if you need to, but it's always nice to use a formula, finding the change between these two. And then we would divide by 2. All right, and so that's our major radius or semi-major axis, and this is our minor radius and our semi-minor axis. And right now, the center is where these two intersect. So that's right there, that intersection point, and that would be at 0, 3 for our center. So the key here is just getting used to the vocabulary, and the calculations aren't too bad on these so far. Okay. So I'll just go going this way. So the major radius is right here. That would be 6 divided by 2. Let's simplify. That's equal to 3. There we are, major radius. The minor radius, 1/2, or 0.5. Minor radius, or semi-minor axis. Check. And then the last one is the center is at 0. X is 0, y is 3. X is 0, y is 3. Got it. See if the next one's any different. An ellipses graph below, the center, minor radius, major radius, and looks like we can just eyeball what the minor and major radius are. So same problem, exactly the same. No need to use the distance formula yet.